Okay. Now, as I said, we want to try and look at different types of examples here. So in this set, we are looking at equations of the form ax plus b, the whole thing squared, equals k, where again k is a positive number. So let's go ahead and take a look at our first example. You have x minus 3 quantity squared equals 25. Now again, we will start by applying the square root property just like we did earlier. So your square root property, again we'll go back and just take a look at it, says if you have x squared equals k, your solution is x equals square root of k or x equals negative square root of k. But instead of having just the value x this time, your x is this whole binomial term x minus 3, but you will try and set it up in the same way. So this will give you x minus 3 equals positive square root of 25, or x minus 3 will give you negative square root of 25. Okay, so you set it up the same way. The only difference here is now you have a binomial term x minus 3 on your left hand side instead of just simple x. So we know square root of 25 is 5. So go ahead and simplify that. And now all you need to do is find your x value. So of course we'll go ahead and move our 3 over to the other side. And you will end up with x equals 8. And let's see what happens on the other side. Again, go ahead and move your 3. And you will end up with negative 5 plus 2, which will give you x equals negative 2. Okay, so again, if you are not satisfied, go back and check your solution into the original equation and see what you end up with. Now if we use 8 for our first value, you'll have 8 minus 3 squared equals 25. And of course we know that 5 squared is 25. So that gives you a true statement. Try and do a similar thing with negative 2. If you replace x with negative 2, you end up with negative 2 minus 3 is 5. Minus 3 squared. Negative 2 minus 3 gives you negative 5. And when you square negative 5, you end up with positive 25. So again, you see that you end up with a true statement, and we can safely say that our solution set is going to be positive 8 and negative 2. Now since these two numbers were different, you could not combine them together in that plus and minus symbol. You have to write them as two separate answers, and so 8 and negative 2 will be our solutions. So you can see how these equations are a little bit different from your traditional quadratic equations, and that's why the square root property works better when you're trying to solve these equations. Right, let's look at this example here. You have x plus 3 quantity squared equals 11. So again, we want to do the same thing like we did earlier. You take x plus 3 equals square root of 11, or x plus 3 equals negative square root of 11. Okay, now square root of 11 we know is an irrational number because you cannot simplify 11 since it's a prime number. So the only thing we can do now to find our x is take the 3 over to the other side. So we subtract our 3, and you will end up with x equals, now you cannot subtract 3 from square root of 11, so we just leave this as negative 3 plus square root of 11. Okay, so you really cannot combine the two, because remember, anytime you're adding radicals, they have to have the same index number and the same radicand, and that's not true here. So we just leave it as it is, negative 3 plus square root of 11. So that's one side. Again, subtract your 3 on the other side, and you will end up with x equals negative 3, and since your radical was a negative number here, you will end up with minus 11. Okay, so negative 3 minus 11 and negative 3 plus 11 will be your solutions to the original equation here. Okay, so your solution set is -3 plus square root of 11 and -3 minus square root of 11. And again, go back and check your answer. If you feel like, okay, this looks a little absurd, just go back and replace these values for x and see if you end up with true statements for both of them. Okay, another type of example. This will be slightly different from what we have done so far. So let's see how to solve this. Now again, remember, you want to try and get your squared term on one side and the constant term on the other side. So again, the first thing we will do is take our 48 over on the other side, and this should end up giving us 4k minus 1 square equals 48, because you will add 48 on both sides. Okay, and now we will go ahead and apply our square root property. So you should end up with 4k minus 1 equals positive square root of 48, or 4k minus 1 equals negative square root of 48. And obviously you can see that 48 is not a perfect square, so we need to simplify that radical. So before we start moving any of the terms from our left hand side, we'll go ahead and simplify the square root of 48. And you can write square root of 48 as 16 times 3. And again, we know 16 is a perfect square because it is square root of square of 4. So square root of 16 is 4. So go ahead and simplify that, which will give us 4k minus 1 equals 4 square root of 3, because the 3 continues to stay inside the radical symbol. We'll do the same thing on the other side before we continue. 4k minus 1 minus, again, 48 as 16 times 3. And that will give you -4 square root of 3. Now after we simplify our radicals, we're still trying to find the value for k here. So that means we need to get rid of the 1 and the 4 on both these sides. So the first thing we do is move our 1 over, add the 1, and you end up with 4k equals 1 plus 4 square root of 3. Again, you cannot add 1 into 4 square root of 3 because of that radical. You don't have a radical term on 1, only on the 4, so you cannot add the 2 together. You have to leave them as it is. Now the last part will be to get k by itself, so we divide both sides of our equation by 4, and you end up with k equals 1 plus 4 square root of 3 over 4. Now I know this looks very tempting to try and add the 1 into the 4 or try and cancel the 2 4's out, but you cannot do that, again, because you have that radical term square root of 3 on this 4 square root of 3 here. So just leave this as it is. You cannot simplify this any further. Okay, so don't attempt adding things that you can't add together. Now again, we want to try and do the same thing on the other side. We want to get the k by itself. So just like we did here, go ahead and add that 1 on both sides. And you end up with 4k equals 1. This time you'll have minus 4 square root of 3. And now we divide both sides by 4, and you are left with k equals 1 minus 4 square root of 3 over 4. Okay, so you will end up with these fractions as your answers. And again, we will say your solution set is going to be 1 plus 4 square root of 3 over 4 as the first answer. The second answer will be 1 minus 4 square root of 3 over 4. Okay, Now, if you plug these numbers into a calculator, 1 plus 4 square root of 3, and divide that by 4, you will see that you end up with a decimal number as your answer. So we're not breaking it down into decimals, but you can find an approximate value for each one of these expressions here. So these are still real numbers, but we're just leaving them in this radical form.